Hello everyone, my name is Wang. Now I'm recording homework 2 of probability and stochastic process. Now let's look at the first question. The first question is, the customer flow at a grocery store can be viewed at a post-position process. The probability of the number of customers arrives in the time 0 to t equals k equals this equation. Suppose the probability that in 2 minutes at least one customer arrives equal to 0.6. First, find the value of lambda. Okay, let's first come into the first question. The question gives us the information that at least one customer arrives, the probability of it equals to 0.3, which means when n is greater than 1 or equal to 1, the probability of it is equal to 0.3, which means the probability of n equals 0 is 1 minus 0.3, which is 0.7. And the t here is 2, so we just apply t with 2 in this equation, and then we can get the value of lambda is 0.18. And the second question, it asks us to find the probability that in 10 minutes at least 2 customers will arrive. So here n is equal to or greater than 2. This probability equals 1 minus the probability of n equals 0 and minus probability of n equals 1. And here the minutes is 10, so t is 10. We imply these values into the equation, and then we can get we can first get probability of 0 is 0.165, and probability of n equals 1 is 0.298. So we can get the probability of n is equal or greater than 2 equals 0.537. Okay, let's look at the third question. Find the probability that in 1 minute exactly one customer will come. Here, the information given to us is the minute is 1, so t is 1, and at least one customer, so exactly one customer, so key here is 1. So n equals 1, the probability of n equals 1 means here lambda is 0.818, which is what we get in the first small question, and lambda is here, and t is 1 and k is 1, and this is k factorial, and then we get the final value is 0.15. The fourth sub-question, find the probability that in 3 minutes no customers come. No customer mean k is 0, and 3 minutes t equals 3. Then the probability is like this, and then we get the final value is 0.583. Now let's look at the second question. Given fx is these 3 values during the 3 parts. First, find a so that fx is a valid density. Second, sketch fx. So now let's first look at the first question. Find the value of a so that fx is a valid density. A valid density means fx, the differentiation of fx from minus infinity to infinity equals 1. And from this equation, we separate this range from 0 and also from we separate the range to three parts. Sorry. The first is x equals 1. When x equals 1, the value is like this, because delta x is 1. And when x is greater than 1 and smaller than is greater than 0 and smaller than 1, the expression is like this. And when x means other value, the value of fx is 0. So this, we sum them up, is 1. And then by calculation, we can get a equals 1. And the second question, sketch fx. We apply a equals 1 to the expression given in the question. And now we analyze the diagram of fx into three parts. The first part is x equals 0. When x is 0, delta x is 1. And the coefficient is e to the power of minus 2. So the value here is e to the power of minus 2, and there's an impulse area which is 1. And when x is greater than 0 and less than 1, fx is e minus 1 times this. We apply x equals 0 to it, and we can get here, this point is 1 plus e to the order of minus 2. And when x is 1, this value is x equals 1, and here is e minus to the order of minus 2. Yeah. And to the other values of x, fx equals 0. So the diagram of fx is like this. The third sub-question, write fx in one line by using step functions. Oh yeah, sorry, I missed something. When x is greater, let's come into the second sub-question. When x is greater than 0 and less than 1, we have to, because we only know the two end values of fx, but we don't know the change or the trend of fx when x is between 0 and 1. So we have to differentiate the expression, and then we can get the differentiation of x is greater than 0, which means fx is gradually increasing. So we can just draw a line increasing. And then we come to the third question, fx. Write fx in one line by using step functions. This question is very easy. When x is 0, fx is e to the power of minus 2 delta x. And when x is greater than 0 and less than 1, fx is this value. So we can express the range of x from 0 to 1 with two step functions. Now let's come into the fourth question. Find capital Fx in analytical form. Still, we separate the form of capital Fx in two parts. First, when x is greater than 0 and less than 1, fx equals the differentiation of f delta from minus infinity to x, and then we separate the range from to minus infinity to 0 and 0 to x. The first part only has value when x equals 0, and when x equals 0, fx is e to the order of minus 2. The second part, because x is greater than 0 and less than 1, so we just apply the expression of fx when x is greater than 0 and 1, which is this. And then we calculate the final expression is e to the order of minus 2 plus e to the order of x minus 1 minus e minus 1 minus x. This is the final expression. And okay, let's come into the final sub-question. Sketch capital Fx. Still, we separate the diagram to two parts based on question 4, the expression. When x is greater than 0 and less than 1, fx is this. So we draw a line in gradually increasing. And when x is greater than 1, when x equals 1, we apply x to here. We can calculate fx is 1. And because fx equals 0 when x is greater than 1, which means the capital of fx is a constant, and also capital Fx is a continuous function. When x at 1, its value is 1, so when x is greater than 1, it keeps the value of 1. So that's the sketch, and the final diagram is like this. Thank you.